Bienvenidos, Ushamdi, and welcome CTS-131, Section 875 students for the Spring 2018 semester at Anne Arundel Community College. This is the Routing and Switching Essentials V6 course, or the Networking 2 course at AACC. And this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 1.3.1.3, our Skills Integration Challenge coming out of Chapter 1. All right, so let's go ahead and dive in and take a look at the topology that we're going to be dealing with here. So we have a manager PC here on the left that's connected into the room 145 switch. And then we have a link between the room 145 and room 146 switch that then comes up here. We've got a connection from the reception PC to room 146. And so we're going to be configuring some host names, some IP addresses. We're going to be doing some password work. We're going to be encrypting some things. And so again, this is going to be a nice soft landing to sort of wrap up Chapter 1. So let's take a look at our requirements. So we're going to use a console connection to access each switch. Now, this sometimes occurs in other packet tracer activities and is a great source of confusion. So this is very, very important. So in order to connect to either of the switches, we need to use a console connection. So from the manager PC, we want to change, or I shouldn't say change, we want to add, come down here to the lightning bolt. If I click on this lightning bolt down here in the lower left-hand corner, you can see it provides me with some additional connectivity methods. And right here, see, when I mouse over that, you can see that down here in the very bottom it says copper straight through. When I mouse over the blue cable, it says console. So what I'm going to do is I'm going to go ahead and click on the console connection here, and we're going to go from the manager PC, and this would be the RS-232, and we're going to drag that around here to room 145, and I'll be connecting to the console port. Now I'm going to do the exact same thing from the reception PC. I'm going to drag a connection over here to the room 146 switch. And again, this is very, very important because there are activities later on in all of the CCNA courses where it'll make a brief comment about, oh, you should use the console connection to connect, and then it goes on with all of these other explanations about what you're going to be doing. And sometimes this gets missed, right? So remember, this is how we're going to be connecting, because if you were to click on the switch, you can see it says configuration is locked, right? If I click on switch 146, so I can't get on to the CLI is the point. So when you see this happen, definitely check to make sure as to whether or not it's telling you to use a console connection to connect in. All right, so let's go ahead, let's name the room 145 and 146 switches. And we know from our previous activities in this course that that's going to be the hostname command. But first, let's get connected up here. Let me move the, whoops, let me get the manager window up. So we're going to come to the desktop here. So how do we connect using that console connection? Well, we use the terminal window, just like you would if you were physically connected to a switch. So for example, I have a real Cisco, and it's going to be 11 right here, I think. Yeah, I've got a real Cisco 1941 router here to which I'm connected via a console cable. So I would come in and I would say, no, I don't want to enter the initial configuration dialog, and then I can connect through via the console port. Right? So it's something very similar here, that I'm using terminal emulation software, and we're doing the same thing here on the PC. So in the previous window, I was using Secure CRT. Here in Packet Tracer, we simply come into the PC, we leave the settings, 96, 8, none, 1, none, and we say, okay, and then take a look. We get connected in, whoops, via the console port to the device to which we're connected. Now, the print here is a little small, and I'll basically MC this because it's I cannot make that print any larger. So you can see here we're at the switch prompt, so we're going to go from user exec, which is indicated by the greater than sign, to privilege exec with the enable command. And then I'm going to move into global config mode with configure terminal or conf t. So if I slide this a little more to the right, I'm trying to give us enough room to work and then to be able to see the instructions. So we're going to use the hostname command, and the name of the switch is room-145. Now you can see down here in the lower right-hand corner, we are picking up some points. So we've got 4 percentage points for that. Now I'm going to go ahead and walk through all of these commands here for this switch and for 145. Then we'll pull up 146 and move on with those activities. So hostname room-145, it says use the 8UBRU password for all lines. Now, when I say do show run, what lines should we see? Well, we know we should see the console line, correct? Because that's how we're connected right now. We should see some VTY lines, the virtual terminal lines to which we connect when we're using Telnet or maybe SSH. And then there should be, excuse me, an auxiliary line. And that auxiliary line is when you hook up, you can hook a modem up to that line. And so in other words, you could connect a plain old telephone service, right, or a POTS telephone line, and they refer to, you'll hear it referred to as POTS, plain old telephone service, or telco service. And you could dial in with a modem, connect to the modem on the telephone line, and then that modem is connected into the auxiliary port, and then you would have remote access that way. And this is actually something that was commonly done a while ago. It's still in use, and it's still something that people do, but it's another way for you to get remote access. And let's say that the network goes down, and the WAN connection that you're using to connect to that switch or router is no longer available, right? And in fact, I'm not even sure. Let me check and see if the switches have the auxiliary lines. Yeah, so no auxiliary lines on the switches. Typically it's on the router. And that auxiliary line, you could connect a modem to and connect remotely. All right, so we're going to be setting it on the console line. So I'm going to say line con 0, and we're going to simply say password 8UB, capital RU. I'm going to say line VTY 0 to 15, so that captures all 15 VTY lines, and I'll use the up arrow to simply recall the command. It's the same command. And so there we go. So we've added that in. We got another grouping of 4 points for each task there. Now it says use the C9WRE secret password. So I'm going to hit exit, and we're going to type in enable password, and I'm sorry, it says secret. Yeah, so one secret. I thought it said password. So we're going to say enable secret, and we're going to say C9 capital W R capital E. And that's going to be the secret password that we use. Now, remember, that is definitely good. That's going to get us to where we need to be, and it's going to get us the points. But remember, the recommended best practice on Cisco today, right, on real Cisco routers is if I go into global config here, and in fact, if I was to quickly say do show run, and we'll go all the way to the end, you'll see here, where's the auxiliary? Yeah, there it is, line aux right there. So there's the auxiliary lines. So when I say enable, before I say secret, I want to choose the algorithm type, and you want to use script, then secret, and then I'll just say ABC123, right? And the reason for that, do show run, include enable. The reason for that is take a look at the strength of this hash. This is a type 9 password. On Cisco, it's type 9, and you can see we've got that $9 there. And this is the hash, very strong hash, as compared to what we're going to see here. So let's say do show run, and take a look. You can see it's got that $1 there at the beginning, indicating we've got this type 5, not too long. So when you're on real Cisco hardware, remember to specify the algorithm type. And this is true for both the enable privilege exec password as well as your user passwords. All right, so now it says encrypt all clear text passwords. Well, we know how to do this. This is a service that the router is going to offer. And what is that service? Yeah, service password encryption, right? So again, we're enabling this service on, and I'm sorry, this is a switch. Same thing on the router though. So we're enabling this service on the switch to encrypt the password. So we say service password encryption. It says include the word warning in the message of the day. Well, let's go ahead and get that in here. So banner MOTD. Now, what is my delimiting character going to be? And I want to definitely give credit to Dennis, who was able to sort out on the previous packet tracer activity where I was putting in the banner, but we weren't getting the points for the banner. It kind of left us out of those 2 points at the very end. And what it required was no spaces between the delimiting characters. So let's do that here. I'm going to say authorized users only, only ONLY, and let's put all caps warning and then little warning, and we'll make sure we cover all cases here, warning, and then I'll do the % as the delimiting character at the end. And we do pick up the points for that, so we should see that when we go to log in. And then configure addressing for all devices according to the addressing table. And we get to talk about something very important here. You'll notice that we're using VLAN 1. So we've got a couple important discussion points here. We're using VLAN 1. And at the CCNA level, it makes perfect sense, right? Because we're trying to learn how VLANs work. We're trying to learn how to interconnect these devices. Now, realistically, never, never, never use VLAN 1. So on Cisco devices, you should never be using VLAN 1. Again, we do it here because we're trying to learn how these things interconnect, and then we'll build on these foundational concepts of how things work by saying this is how they should work properly, right? And that's when we'll get into disabling VLAN 1. But for now, we're going to be using VLAN 1. So the room 145 switch, we're going to be putting an IP in here and an odd IP at that. So we're going to go into interface VLAN 1. And this is referred to as a switched virtual interface. It is a virtual software interface on the switch for VLAN 1. There is no physical port that I plug into that is VLAN 1 with this IP, right? So this is any PC connected to the switch that is in VLAN 1 will be able to access this port. So we're going to say IP address 128.107.20.10, and this is a /24. In other words, in dotted decimal notation, a 255.255.255.0. And we pick up some points for that. Yeah, we got 8 points for that. And we're going to say no shut, right? I'm going to make sure we bring up that interface. And we've also picked up a few points for that. So that takes care of the VLAN 1 IP on the switch. Now, you'll notice, and I want to make sure I don't say something that's incorrect here. I'm looking real quickly at the requirements. Yeah, you'll notice that we didn't put the IP default gateway on the layer 2 switch. Why not? Exactly, because everything you see here in this diagram is in VLAN 1. So in other words, VLAN 1 spans our entire network. And when we get done, we should be able to ping back and forth here, right? And again, this connection here between the switches, and this causes, for new learners, this will sometimes cause some confusion because you'll look at this and say, oh, that must be a trunk port, right? Well, it could be a trunk port, and that's a possibility. And the use case for the trunk port is when I have more than one VLAN that needs to transit between these switches. So in other words, let's say we had another PC over here. We'll say this is PC, or what do we call it? We'll just say PC3. And then I had another PC over here, PC4. And let's say that this guy's in VLAN 9, and this guy's in VLAN 9. Now remember, these guys are in VLAN 1. So how would we do this? Because if this connection right here is VLAN 1 only, will these two VLAN 9 hosts be able to talk to each other? And the answer is no, because there's no inter-network connectivity there. Now, if it's a trunk link, which by default allows all VLANs to transit across the link, then they do have connectivity. So keep that in mind as we move forward in the course. In other words, this is perfectly fine. We've taken two switches with basically the default VLAN configuration, because VLAN 1 is the default VLAN that you will find on every port of a switch. If you've done no configuration to it, if you take it out of the box, plug it in, turn it on, every port is in VLAN 1. So connecting these things together, as long as we've got IP addressing properly configured between these two guys, this is all going to work without an issue. In fact, you don't even need to put the VLAN 1 IPs on these switches for the connectivity to work. The reason we have the VLAN 1 IPs on here is so that from reception, we could ping the switch, right? Or we can get to both switches. And from the manager, we can get to both switches. However, for connectivity between reception and manager, no IPs on the switches are needed. Remember, these are simply layer 2 switches, and this link, which is not a trunk link, is simply extending your broadcast domain. It's simply extending VLAN 1. It's allowing you to grow VLAN 1 between these switches. In fact, I could put another switch out here, right? I could put another switch and then with a PC. And as long as everybody's on VLAN 1, this guy can reach that PC and this PC. I could do the same thing again. And as long as everybody on the switch, everybody's in VLAN 1, we'll say PC 9, PC 9 can get to that PC, to the manager PC, and to the reception PC. Because again, we're just extending, we're growing, expanding the broadcast domain that is VLAN 1. And this is very different from when we start to add additional VLANs in, and these become trunk ports to allow multiple VLANs to transit them. All right, let's clear the screen here. And I just wanted to make sure I touched on that because those are core foundational concepts that if you don't understand when we get to trunk links and we get to additional VLANs appearing on setups like this, it becomes very confusing. So make sure you're clear on that we are dealing with a single broadcast domain here, and we're just extending it by plugging in, and this can be a straight through cable on modern day switches. I think we may be saying it's a crossover cable here. I'm not sure. Let me see what it says. Yeah, I think we're saying it's a crossover cable. So on older switches, yes, it needed to be a crossover cable. And actually, no, I don't want to delete that. But on newer switches, right, on newer switches, it does not have to be a crossover cable because you've got what's called MDIX, right, media dependent, I think it's interconnect. So media dependent interconnect, where the switches are smart enough nowadays to figure out exactly what it is that you want to do. And I'm trying to get rid of this arrow here, and let me get back over to, there we go. Okay. All right. So we've got the warning message on there, configure addressing. We did that for that VLAN, and let's save, whoops, got to get back on the PC. We're connected into the console port. Let's save our configuration. And so the Dropbox message has nothing to do with our activity. So now we're going to say, we'll say copy running config startup config. Now, I can say that, and that works, and that's great, but very easy to say write memory, which is the same command. That is the equivalent command of saying copy running config startup config. You simply say write mem, or WRI mem, and that's what I use, right? Much quicker, does the exact same thing. Okay, so that takes care, verify connectivity, of switch 145. So now let's jump onto the reception PC. Let's go to the desktop. Let's go to the terminal window. Let's say OK. And I will move through this at a little quicker pace as we won't have as many sidebars to discuss. Excuse me. Okay, so we hit enter a few times. You can see what's sort of a default configuration here. And we're on the switch. I'm going to go into privilege exec mode by saying EN for enable, and then I'm going to say conf T for configure terminal to move me from privilege exec into global config. And let's go ahead and set this up. Let's get the host name set up. So this is room-146. Let's get the lines. So line con 0, the password is going to be 8UBRU, and then line VTY, VTY 0 through 15. I'll do the up arrow to pull that command back because it's the same password. And we're going to say for the secret password, we'll exit out so that we can say enable, enable secret, and the password is going to be C9, capital W, lowercase r, capital E. And then we encrypt all text, all plain text passwords. So service password encryption. And where were we at? Encrypt all plain. Include the warning message. So banner, MOTD. I'll use the % and I'll say authorized users only. And then we'll say warning. We'll use little w or all lowercase, not warming, warning, and then warning. And then we end, right? We put our delimiting character there, and let's see if I put a space and then the %. Does this give us any points from 62? It does. So this packet tracer activity, that's okay. And the previous one we did that Dennis caught and figured out, and well done, Dennis, you can see that it works here, but it didn't work in that previous activity. So if you think you should be getting points for the MOTD, go ahead and play with the spacing there. Okay, and finally, configure addressing. So interface VLAN 1, I'm going to say no shut right out of the gate so I don't forget. IP address 128.107.20.15. So some very good, and then 255.255.255.0, so a /24 where the first 24 bits are dedicated to the network portion of the address. And that is why we have all 255s in the first 3 octets when we write out the subnet mask in dotted decimal notation. And so we go from 79 up to, and we're not getting, we didn't see any points for that. Did I get that right? 128. 107, 20.15. That is correct, but it doesn't look like we got points, so we'll drive on anyway. Now let's save our configuration. So it looks like we may have been missing something, or there might be something that's implied that we didn't get. So verify connectivity between devices. So from the manager PC, I'm going to close the terminal window down. Let's bring the command prompt up. So can I ping the PC to which, oh, you know what it is. Maybe we need to configure that. I'm sorry. It says configure addressing for all devices. All right. So here we go. I assumed the PCs were going to be set up, and they are not. And so I think this may be our missing link here. 20.25. And you can see it puts in what subnet mask, what class subnet mask is that by default. Exactly, a /16, a class B, because 128, the value in the first octet of the IP, falls into the class B range. However, we have subnetted that classful class B address down into a /24. So we need to fix this, 255.0. Now, default gateway. Do I need a default gateway? No, the answer is no. Again, remember, everything is in the same broadcast domain. And when I say broadcast domain, here's how I want you to think of this. I'm going to give you some synonymous terms. So when you hear or see VLAN or subnet or broadcast domain, that's what we're saying, right? So a VLAN is a subnet, is a broadcast domain. So since we're not doing inter-VLAN routing, I don't need to tell the PC, hey, if you're going to something that is in a different VLAN subnet broadcast domain, here is the default gateway address. But everything that we're working with here is in the same broadcast domain, subnet, VLAN. Those are synonymous terms, right? A VLAN is a subnet, is a broadcast domain. So No need for the default gateway. And we went to 91, so we should be good. And let's go ahead and go to the command prompt, and we're going to say ping. And can I ping 128 dot, and what is the, this is the manager? I'm on the manager. So the manager switch is 145. So 128.107.20.10. And I should be able to successfully ping 128, and maybe we time out, we do, and then it works. Now, if I can ping my manager switch, I should be able to ping the reception switch, because remember, we have a link between those two switches, which is extending the broadcast domain VLAN subnet, right? It's extending the broadcast domain, right? And so let's go ahead and ping 128.130, I think it is, yeah, 30. And so let's see, can we ping the switch on the other side? And we time out for the first one. And maybe this is where we might be missing some points. So we're timing out. So I can't ping, and let me make sure I got the right IP address, 128.107.20.30. So I can't ping across that link yet. So let's come to reception, and let's see if we get similar behavior. So I'll come to the command prompt. So can I ping the switch to which the reception PC is directly connected, 128.107.20.15. So let's see, can I ping, and actually, did I put addressing information on this PC? I have not yet. So that's going to be a problem. So let's add this in, 128.107.20, and this is the reception, and reception is, oh, you know what I did? You know what I did? I just realized I was looking up at the room number instead of I was looking at the switch IP instead of, okay, so I think I see the issue here. So 128.107, do you know what the issue is? So think about it. The reason that that didn't work, if you're paying attention, you're probably screaming at the screen right now saying, wait, Travis, no, go back. You need to fix something. And we're going to do that right here. So again, this is common, right? I look up, I grab the wrong address, I throw the wrong address in here. I'm talking about different things, and so we end up with an error, but that's okay. It's a fortuitous failure because it gives us an opportunity to troubleshoot. The reception PC is actually the 128.107.20.30, right? That is the IP. We need to get the right subnet mask in here. No default gateway required. And we're not going to be able, this isn't going to work yet. If I come back to the manager PC, and I click on the password. Did I get that right? I did get that right. Okay, so that was correct. I thought I might have gotten that wrong. Okay, so to the reception PC, can I ping the switch to which I'm directly connected? 128.107. Whoops, 128.107. I thought I had put the wrong IP in there. .20.15. So can I ping the switch to which I'm directly connected? And I can. Now, can I ping the switch on the other side? In other words, 128.107.20.10. And you can see the completion percentage is at 100, and there we go. The request timed out initially. So it looks like the activity may have been, and let's make sure that we can get all the way around here. In fact, if I come back to the reception PC, can I ping the manager? And the manager is 25. So we've got connectivity. So that ping from the manager to room 146 should have functioned without issue. And it didn't initially. Let's come over to the manager and let's see. Can I ping 30, which is reception? I can ping all the way to reception. Can I ping 15, who is the room 146 switch? And this should work. And it does. And can I ping 145? And that should have worked initially. We should not have needed to put an IP on the reception PC in order to ping the reception switch. So again, we've got all of our points down here. We've got connectivity across the network. Again, remember, key takeaways here. This is a single broadcast domain. And a broadcast domain is a single VLAN, is a single subnet. Those three things are synonymous. Remember that. Very important. And this link between these switches. The first key point, it's a crossover cable, and that's fine. That's going to work. But a straight through cable on modern day hardware will work as well. It will actually take care of any issues with the pinouts on your cables. All right, so this is going to wrap up Packet Tracer Activity 1.3, our Chapter 1 Skills Integration Challenge. All right, thank you so much for watching, and I will talk with you soon.